Good morning, friends. Now we are discussing processing of n jobs through three machines. So, in sequencing of operation research in module number 5. So, in earlier problems, we have seen a n number of jobs through two machines. Now, n number of jobs to be performed through three machines A, B, C in the order A, B, C. That is, whatever job is taken, first it has to get processed through machine A, then it has to enter machine B, then to machine C. So here are the processing times given. So if the job number 1 enters into machine A, the time taken for processing is 311. Similarly, the job number 2, it enters the first machine, so it is T12. So like this, so the nth job getting performed on machine 1, so that is A, machine A, so it is T1N. So likewise, so the different times, processing times are given in the table, maybe in hours or minutes. So how to proceed? So optimal solution will be obtained by taking the minimum processing time on machine A, and then we are taking minimum of T 1j is greater than or equal to maximum of T 2j for j is equal to 1 to n. Then the minimum processing time on machine C is at least as great as the maximum processing time on machine B. So that is minimum of T3j greater than or equal to maximum of 2j for j is equal to 1 to n. So the first step is examine the processing times of the given jobs on all the three machines. If either one of the above two conditions holds good, so then we'll go to the next step, otherwise the algorithm fails. So we are introducing two imaginary machines G and H with the corresponding processing times. So here if we take A and B. So the processing times of these two machines will be added to get the imaginary machine G. Similarly, the processing time on the next two machines B and C will be added to get the another imaginary machine, that is H. So the processing times of the first two rows will be added to get the imaginary machine G, and the processing times of second and third row, that is B and C, will be added to get the imaginary machine H. So A and B will be added together to get the imaginary machine G. B and C will be added to get the imaginary machine H. So now we are following the Johnson's algorithm as usual to determine the optimal sequence for n number of jobs as discussed in the earlier case. So now we'll proceed to the numerical. So find a sequence which minimizes the total time required here to complete all the given 5 jobs on the 3 machines A, B and C in the order A, B, C. So the processing times is given in hours in the following table. Now the 3 machine problem has to be converted into 2 machine problem, for which we are following the condition given, right? So that is, first you see the minimum processing time in the first row. So that is on machine A. So here the minimum processing time is 6. Similarly, in the last row, you search for the minimum processing time. So that is here. So that is 4 in the last row. So the general concept is we have to start the project with simple activities in the minimum, and we have to finish the project with simple activities in the end. So that's why we are considering the minimum processing time in the first row and minimum processing time in the last row. In the middle, so maximum of TB. So that is out of this processing times. So maximum time is 6. So that is written here. Now consider this 6, the condition minimum of TA greater than or equal to maximum of TB. So 6 is equal to 6. So that is satisfied. But this condition minimum of TC is not equal to max or greater than maximum of TB. But any one of the two conditions is satisfied, so that is okay. So we'll convert now the 3 machine problem into 2 machine problem. So we will consider 2 dummy machines G and H such that the first 2 rows A and B processing times will be added to get the processing time of the dummy machine G. Similarly, B and C will be added to get the dummy machine H processing time from J1 to 5. So G and H will be obtained by adding. Okay, so A and B will be added. A plus 8 plus 5, 13, 10 plus 6, 16. So like that we are getting the processing times on machine G. Then B and C will be added. 5 plus 4, 9. 6 plus 9, 15. 9, 15 like this. So now the procedure is we know when we have 2 machine problem using Johnson's algorithm, the optimal sequence for the above problem is obtained like this: 3, 2, 5, 1 and 4. Now the 2 machine problem is now converted back to 3 machine problem. So the optimal sequence obtained is 3, 2, 5, 1, 4. So now we know how to find out the time in and time out on these 3 machines. Find out the idle time on each machines. So we got the total processing time as 51 hours after all the jobs are over. So machine A, so get its work completed on 42nd hour itself. So 51 minus 42, so that is 9 hours for machine A. Then 51 minus 45, that is 6 hours on machine B, and 51 minus 51, that is 0. So total idle time on machine A, summation of all this vertically, so 9 hours. Machine B, summation of all this, 31 hours. Summation of column 3, so that is machine C, 19 hours. Total processing time is 51 hours to complete all the 5 jobs on all the 3 machines. Thank you, friends.